In this episode of Finnogrek Machining, we are going to start a new project. Well, despite our old project is still ongoing, but I'm having a pause. It paused for a while. So, but this one is really something I don't need, and it's a rotating welding positioner. Rotating table or whatever you want to call it. And this one is going to have some bearing and quite heavy stuff. A while ago I bought a 4-jaw chuck, not the Bison but an old one, and that one proved to be so worn out that you cannot possibly use it in a lathe. So, but it's a perfect candidate for this kind of application. So today I visited, hello guys! I visited the nearby steel, what would you can buy steel stuff from there. And anyway, I bought something and it is this, this piece of material. You can do some heavy lifting with this one, and this will be the housing for the bearings and the shaft, so it's a heavy duty one, so that you can hang on stuff which is really heavy on that one, because the chuck is really heavy duty, so this should be as heavy duty as the chuck, naturally. And then I have some bearings and whatever. I have now collected stuff. One thing that I don't have, I need to bore at the center from here. It's a long one, and I need a boring bar, and obviously you cannot do it with this. So, but lucky me, I'm having its big brother on here. So this I bought from Frankfurt flea market. And it was really affordable in price. There was a reason for that. It's left hand. You just turn it the opposite rotation, maybe put the boring bar upside down, and there you go. The nice thing is that it came with the inserts that belong with this one. Okay, and these are Cermet. So that will be a very good one. And then I have this to hold it, but the hole here is obviously not a good one. So as the first task, I need to make a bushing for that one. So let's start with that one. Okay, this is a piece of material I cut from the, I have a long shaft of this one, so I cut just a piece of suitable length. Okay, now we should chuck this one in. And so put it there, right? Yeah? Okay, let's see. Let's not drop that one there. So we should be somewhere around the center. I try to put this, I'm putting the top on under this jaw, so I can see that our center is somewhere there. Then I can see the lines here, and the inside seems to be like that. I put all the other jaws on the same position, about. So this makes my task of centering it quite a lot easier. Okay, it was a little bit off, I believe, because okay. Okay, we are approaching the, I believe, this might be, I'm already trying to center it with the jaws. I'm looking here, not on the jaws, but here with the lines that we have in the chuck. And this is a little bit too much in. And these are quite alright. So let's see how it looks. As you can see, it's already quite center. So what I will do now, I will make some stick out to it because I just want to do that. Well, yeah. Okay. Let's tighten it just a little bit so it doesn't move by itself. Okay. So now what I'm going to do is to dial it in. We need more, absolutely we need more. So let's take a little bit out. Well, around there I believe. Oh, it wants, okay. Let's see, I tighten it there and we will see. Well, it's still, luckily it's still about 15 millimeters inside there, and we have enough material here to make it flat on that side. And now, well, well, if this would be hardened, I wouldn't chuck it directly, but I would be using packing in the jaws. But since it's not hardened, I can almost do whatever I want. So at the moment it's like that. Okay. Then this should be about in the center line. It's not that critical actually. Let's go there. And now well, we are turning this down quite a lot. So for this reason I will now, it doesn't matter if it's not perfectly straight, but I would like to have it quite straight even though. So let's see how far were we. Oh yeah, 1 millimeter at least. No, not the whole millimeter. So aligning with the lines on the chuck really, because this is now quite easy to do. So now this is high point on the back side. So I would like to loosen this one, but I don't want to loosen them. So I first tighten this one, which now should move. Yeah, it moved, but very little. So let's loosen this one, and then the opposite side, tighten. Loosen. And tighten here, the opposite side. Well, we are now within 3/10 of a millimeter. Probably the other jaws are now, no, this is that, and that's now, let's tighten this first. Yeah, okay. Then loosen a little bit. Tighten. Loosen. This is not really very bad thing to do. Let's see how it feels now. Looks now. We are within 0.1 millimeters. So this should be now tightened. This is about the same. This should be loosened and this tightened. Let's tighten this one. Okay. I have noticed that this particular chuck needs quite a lot of force. Oh yeah, I'm pretty sure it's off now. No, it's not. It's, well, it's quite good actually. So now comes the tricky part. I need to go to here and see how much whiplash we have there. Not a lot. Quite little. So this place here is now our high point. And now I have learned that you don't need a lot of bumping force with this, and this is probably the wrong tool. I will use this brass piece to just very gently tap it. and it's still a little bit high. High. Well, a lot of this material needs to come off, so maybe we could accept that for a while, but let's see how much it moved here. Not a lot. So this is by no means in absolute center. No. Yeah, I will accept that one. And now the last check that it's really tight everywhere. That's tight, 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 tight. Did I do this already? Yes. Well, whatever, it's tight. So now it's there. We have it inside 0.1 millimeters. Well, in this case it's okay. So now I first will face this one, and after that I will put a center there, and then I will turn this to the correct diameter right away. What was that? Oh yeah, we have a broken chipped insert. Well, our goal is 32 millimeters, so we have a little bit more to go. It should be 32.5 millimeters about. Yeah, it is there, if you can see. 32.5 millimeters. I will change the measuring gear to micrometer, and first of all let this cool down. This is scalding hot, not scalding but really hot, about 70 degrees I would assume. Over 60 anyway. Yeah, so I will let it cool down before I turn it. It's just a good practice. This one doesn't need to be down to 1/100th of a millimeter, but I want to make it that way. Okay, now this is cool. Well, a few cups of coffee, some buns, and well, it's cool. So let's see. Well, 32.52, I think. And the other end, let's see how much taper we have here. Shouldn't be much, but there is, I know. Well, we have 3/100ths of a millimeter taper. Maybe 5. And it becomes smaller now because I'm not hugging here. I will take first 0.25 millimeter off, and then I measure it again, and then we take whatever was left after that. So, but since everything is now cooled down, now I touch it. There you are. 0.25. Okay, slow speed, a little bit more speed. Well, we are going to get string chips, believe me or not. I'm pretty sure of that. Let's see how long strings can we get now. That's too far. This will be a really slowly process now. Let's go. No, not too bad. That's actually okay. And as you can see, the surface finish is, well, reasonable. So I'm running at about, 1300 maybe RPM, and feeding is, so it's 3/100ths of a millimeter per revolution. Okay, and the depth of cut is 0.25 millimeters, and then you get chips like that. Okay, they are not stringy long things flying all over the place, but manageable. Okay, didn't warm up, nothing much. So let's see what we have here. Well, we have 32.24 24 and a half, maybe. And the other side then, so at the moment it looks like we should take 25.5 hundredths of a millimeter. This is a little bit under, it's smaller from that side, but it's not much. So actually the taper is, it's larger from this end and smaller from this end. So this end will now dominate. I will actually make this end 32 millimeters exactly, and the other one will become whatever it does. So we will be taking 0.25 and a hair more. Okay, 0.21, 5 and a hair more. There is our hair. Well, wish me luck. Okay, now I will actually lock the carriage here. It's locked. And then I feed with the compound just a tiny amount, like that. And then I feed out with my just a manual feed. So I will clean that surface. Like that. There you are. Well, let's see how near 32 millimeters we got it. Well, 1/100th of a millimeter over. Yeah, this is probably a little bit under. Yeah, 1/100th of a millimeter under. So it should be quite exactly in the middle. Yeah. So, the outside diameter is now correct. What I will do next, I will drill a hole through it. And this one should be quite exactly 25 millimeters. Well, this is an 8.5 millimeter drill. I will now demonstrate how I start a hole straight. It's not very uncommon that when you have a center drilled hole like this, and then when you push a drill in, it will start to wobble. Yeah, it more often than not. So what I will do, I have here this tool. I'm not going to use it for cutting. I'm actually using to push the drill if it starts to wobble. So I can actually straighten it back by pushing it even so gently. Okay, let's hope it starts wobble so I can demonstrate that too. So we need not so much speed here. Let's see how this is. Well, it's about right. And well, eye protection, please. And oh yeah, let's put some cutting oil in there and there. Oh yeah, and for this to work, the cutting flutes must be horizontal. Yeah, maybe you guessed that already. So let's see what happens if it starts to wobble. You can see it starts there. Unfortunately not. So this is not needed. Yeah, let's take it away. Not needed this time. So Well, what I'm doing now, I will drill a hole as far as this goes, and after that I will be using this little bit longer drill. Well, this first one is just because this is so long, it flexes like this, the long drill, so I want to make it quite long here so it guides the rest of the way through. So yeah, let's drill. It's a 17mm drill now. Hopefully this will not squeal a lot to me. It might. Let's see about the speed. Well, of course this is not what we want. That's more like it. And we have... Yeah. And before I do anything, I will squirt quite a lot of this stuff into the hole. Actually, it should go in front of the drill, the oil, so I don't need to put it that often into there. So now, this. Yeah, the speed looks like right. Yeah, true. And now an even larger drill will be 22mm. Well, this is 23mm. Should be, yeah. So, a little bit larger. But we should be good with this one. So, our goal is 25. Let's see how the flutes are ground. I might need to regrind those. And this is fast again. Now we need to go down with speed. Yeah. Yeah. Oh, scheisse! Hot! Really hot. So, well, next step is to bore it to 25 millimeters. Okay, well, I first tried to bore this with this boring bar, and it reaches, but the stick out became so long that it was utterly musical. So it was chattering all over the place, and I couldn't get rid of that chatter. So I replaced it with this one. The only thing with this is that the insert has such a geometry that it must be run that way. But, well, that's not a problem. So I'm taking 0.2 millimeter passes here, and I already took the first one, and it was amazingly straight. It already cleaned the hole. So, when I get it this time through, I will measure the hole. And it doesn't chatter at all. Very good. This is now, the inner diameter is 23.5 millimeters quite exactly. So we have 1.5 millimeters to get off from the diameter. So I will do this in 0.3 millimeter passes. Doesn't chatter, which is really good. Okay. So this will be 5 passes altogether. The surface is even better. Okay, now we will see what it is, what the situation is. It should be now. Hopefully it's not sloppy. Yeah. This is a really good fit. And now, let's see. I would like to take the chips away, so I can I slide it all the way through. Yeah. And this is super fit. Okay. Now that's done. Now that we have a decent sleeve, I just turned this thing around in the lathe chuck and then beautified this end. Just made it concentric and nice to handle. So nothing more in there. Just plain turning. Now what I have started here is to slit this all the way across, and if you look, I'm using the boring bar itself to support this one, to keep it in place. There is a parallel under here, which is then supported by a stop here at the back, like that. And and then this shoulder is leaning on the end of this parallel, so it cannot move that way. The cutting forces are mainly that way in this operation. It doesn't introduce any sideways, I cannot say any, but it won't introduce too much cutting forces in sideways. All the cutting forces are axial here. So there is a radial force downwards, and maybe up as well. I don't know. Maybe up, yes, because it's rotating. It's trying to pull it up a little bit. But this is quite rigid. And you can also hear when you do this operation that it's not too bad. Well, I will now do the slitting. Well, what happened here is when I finally got it through, this thing is now binding tightly here. It doesn't want to move at all. So what really happened was that when I got it slit, it made like this. It's very usual when you have a piece like that one, and when you slit it, it will bind. That was one of the reasons why I used the boring bar itself to support it. So now it couldn't bind my slitting saw. If I would have attached it otherwise, it would have bound that saw instead of binding itself into the boring bar. But, well, this shouldn't be too bad to get out from there. Well, this piece now, it was quite easy to get rid of. I just had a screwdriver stopped into the groove and then it slid off, no problem at all. Well, after spreading this out with, I just hammered in a screwdriver and tried it out several times. So then I got it working like this. Now it slides in. It's really like there is no play at all. And furthermore, when you put this one into your holder like this, and then if you lose this one, which is actually spreading this thing, so then it's all tight already, even though these screws are not tightened. So, well, my point of view, this is ready to be used. Well, we successfully turned that little piece of material into a decent bushing for my boring bar. Well, not too hard to do when you know what you do and you have the equipment to do it. So yeah, this works well. The only obstacle here was that when I opened the side of this slitted, so it started, it closed like a clamp cell, and I needed to hammer it a little bit wider, and now it's okay. Well, yeah, it is okay. So that's about this episode. In the next episode we will really turn the bushing for this bearing housing, the bearing housing itself. It's a rather large piece of material, and we may encounter some problems with that one. But let's see. But that will be in the next episode of Finnugric Machine. Till then, see you!